Here to this community, both the same thing. It's lovely to be back. No, it's Quentin. Quentin's right. Yeah. Well, it's a long time ago. I first came to St. Peter in 1980. 42 years. Right. That is a long time. That knocked me into a cocked hat. And then someone fires the starting pistol. Have you had your tea? Have you had your tea? See you later, Bob.
questions that you don't want asked in front of everyone, although there'll be an opportunity, please do come and chat at the end as well. Alan, who's next?
Yes, okay. So, thank you very much for coming. And we're going to give just a short presentation, give you an overview of some of the things that we're looking at. And really what we want is a kind of informal exchange. So, ask as many questions as you like. We're all here to answer the questions you've got. And this will just give you a little bit of a flavour of what we're dipping into. And as Kirsty says, this comes under the umbrella of the Peaks Management Plan. And in particular, we're obviously representatives of St Helena Government, St Helena Research Institute, University of British Columbia, and as Kirsty says, actually, the Centre for Ecology and Geology. So as a little bit of background, why is it important? Why is genetic variation important? Why might we want to know about it? Really, it comes down to a few important things if we're going to conserve plants on St Helena and other places. But on St Helena, most of our endemic species are in kind of small and sometimes fragmented populations, and sometimes they're very isolated from each other. And what that can mean is that those populations have a tendency towards inbreeding, because there's not much genetic variation within small populations. That then might go on to say, well, they may not have much ability to cope with environmental change or climate change because of that. And they also could be prone to disease because the genetic variation is quite small in those populations. So if we know something about populations, and if we can categorize or quantify some of the genetic variation, we can hopefully find out if we can increase it in those populations. And that increase might lead to better success in things like propagation, horticulture, and it might help combat all of the things that I've just mentioned. So that's basically why we might want to know about genetic variation. And the other big reason why we might want to know about it is because we want to stop plant extinctions. And this isn't just something that's happened with St Helena, this is a global phenomenon. And many scientists now believe that we're entering a 6-month extinction. Now geologists will say, hang on a minute, can't say that, that takes millions of years to happen. But what is happening is quite scary in a way. You probably found out that during the pandemic, what scientists actually do is produce graphs. That's all that we do. So here's one. There'll be another one, so hang on. And this graph basically shows you an accumulation of extinctions over time. And the red line is those accumulations globally. The blue line is accumulations for islands only, and then the green line is for continental. Now, you can see they're all going up. So we get more and more extinctions over time. And this line here is what we should expect. So that's how many extinctions we would expect over that timeline. What you see is all 3 of those lines are massively above. So we're way above the background extinction rate, as it's called. And not only that, we're doing it in such a short time. That's only a few centuries here. And normally, those mass extinction events happen on a much broader time scale. We're talking something about 10 to 15 million years for one of the biggest, which was the Permian mass extinction, when about 90% of all animal life disappeared. So that took a long time, and we're doing it over a century scale. So that's quite a scary thought. So it's not a happy thought. So what I want to do is project some happy thoughts. And there we go. Yes. Boom. You can if you like. I don't care. Yes. I'm from Scotland, if you didn't The weekend was a glorious weekend for me. The other thing, of course, to remember about St Helena is it's part of the Overseas Territories Fund. And the Overseas Territories are extremely important for global biodiversity. Now, these are just some figures from the RSPB. But they highlight how important the Overseas Territories are. And they're much more important than mainland UK. For example, there's only 348 known endemic species in Great Britain. It's not very many, but we've got more invertebrates on St Helena than we have in total in Great Britain. And there's something like 47 species of flowering plants that are endemic to Great Britain, which is not bad, but they're mostly in one or two genera. So there's not a great breadth there. And most of them, in fact, are not really great species anyway, because they're all what we call micro-species. So if I gave you one sorbus and another sorbus, you'd probably go, hey, the same. And they do, but on a genetic level, they differ. But let's contrast that. 30% of the endemics in the Overseas Territories are from this island alone. That's how special this place is. And we've got 45 endemic species here, which is almost comparable to the UK mainland. You remember, the UK itself is a much bigger place than here. And there are other factors for that. But that number is also rising. 45 endemic species, we are describing those species as well. So, a little story to kind of illustrate why genetic variation is important. Now, I'm sure you're all aware about the bastard gumroot, how it went down to 2 individuals, and how Vanessa and her team have basically made a success story out of just having 2 individuals left. But I want to diverge from that a little bit, because there's another story, or a subplot, shall we say, within that story itself. And it has to do with the false gumroot as well as the bastard gumroot. And there was basically a gene bank that was thought to be for bastard gumroots, but people then started to look at it and they thought, this doesn't quite look right. I think there may be some hybridization here. And so we were asked to have a look at some of the genetic variation within this stock, specifically to find out whether this gene bank was hybrids or not. And we did. And this is my second graph. And so what it shows here, on the left-hand side is gumroot and scrubwood. So don't worry about that too much. But here, over this side, what we've got at the bottom is the false gumroot is the blue triangle. And at the top, the red square is the bastard gumroot. And then in between, you've got all these triangular things that are either pink or kind of yellow. The spread between the two periods indicates that they're hybrids. They possess genetic variation between the two. So we've answered that question. Hybridization, yes, probably has happened in that case. So they weren't the pure bastard gumroots that people thought they were. But what was really interesting, and what we weren't expecting, is that these pinky ones, they all have genetic variation in them that neither the bastard gumroot or the false gumroot have currently. So the presence of this hybrid population actually increases the genetic variation of Comedendron gumroots. So they're extremely important to conserve this population. Otherwise, if we got rid of them, we'd be losing genetic variation within the whole of the Comedendron population. So that's one example, and this is just to kind of show you the approaches we're sort of taking to try and categorize genetic variation. And so these are some example species. We're looking at the Diana's peatgrass, the jellicoe, the crownflower, and we're using molecular techniques, and that's largely what Quentin is leading on is the molecular side of things, and what I'm helping with is I perform glasshouse trials back in Edinburgh in semi-controlled conditions, so we can look at plant morphology and we can look and see what differences are there under semi-controlled conditions. What that means is you take out the environmental variation from the plants that we know contributes to differences in morphology, and you are basically looking at an expression of the genetic variation. So it's quite a useful technique in combination with the molecular techniques. And just to kind of give you some results of some work that we've done in the past, so you all know Old Father Live Forever, and all the guys are going, yeah, it's Old Father, yes, Old Father, it's for us, Old Father. So, well, we kind of looked at some plants under Vanessa's direction and looked at them in Edinburgh. What you actually find is that there's two different types. It's not the same. I think you can sort of see some differences there between the top one and the bottom one. And there were some molecular differences as well. And so what this means is that we've actually got two different plants on Centellina. And it also looks like the flowering times are at different points in the season for both of those populations. And we don't just have Old Father, we also have Old Mother. And this is going to be a new subspecies that we've submitted the paper, and we're naming it in honour of Vanessa until it all comes out. So that just gives you a flavour for what we do, and hopefully you'll have some questions about what we're doing and where we're going. We also have a display that Vanessa has put together that has well, I shouldn't say should have, has some plants over there, and you can look at them and see if you can detect any variation, and there's some microscopes set up as well.
Alan, should I say something about the peat grasses now?
Yeah, sure.
Because we've got, thanks to Vanessa and the nursery at Scotland, we've got the Old Father and the Old Mother there. And your challenge, would you care to accept it, is to see if you can see the difference between the two. We've got microscopes with a leaf of each over there. Can you see the difference? And what do you think of that difference? And we've also got these peat grasses. These are actually sedges rather than true grasses, but on Centellina we call them the Diana's peat grass. And it used to be thought that there was only one. Well, a long, long time ago, they thought that the high peak one and the Diana's peak one was different. Then they thought, well, there's only one. And then was noticed by when the team at Scotland, the nursery team in Scotland, started growing these, that under cultivation they look different. And this one is from the barn. This one is from High Peak. And this one is from Diana's Peak. And they look slightly different. So what Vanessa did was to send some samples for genetic analysis to us at the University of British Columbia. We ground them up and we looked at the DNA. And I was, well, when I saw the results, I nearly fell out of my chair. I don't think I've ever seen in closely related species such a big genetic difference as there was with this barn variety. It was, well, I was expecting it to have tiny differences in those. It was actually really, really different. So something happened on the barn where, you know, something was, became a unique variety for the barn. And even we found differences between Diana's Peak and High Peak, although they're less advanced. So what I'd really like you to do, as well as looking at the old father and the old mother and seeing whether you can see that, is come up and have a look at the leaves of all three of these and see whether you can see a difference between the leaves. And I'd love to say there's a large cash prize for the person around. I don't think we have that. Do we, Kirsten? No. The project budget doesn't run to that. But anyway, if you can try and find differences in the leaves of all three, that would be great. Not only how the leaves grow, but also the surface of the leaf. Look at all aspects and see whether you can see differences, and then come and tell us. Particularly tell Vanessa, because she was faced with trying to sort these out in the nursery, because we don't want to mix them up. I think Vanessa knows very well how to tell them apart. Maybe you can give us some tips. Anyway, Alan, do you want to lead off with the old father?
I just want to leave people with that happy thought. It's where I'd like to leave it. Yeah, I mean, if you want to come up and have a look, or if you've got any questions you want to ask at this point, please feel free. It doesn't have to be in such a formal kind of sit-down thing. You can all go about and chat.
I just wondered if you want to say how you apply that back to the field. So how does that now contribute to the Peaks project?
In terms of...
Or Vanessa.
Sorry, let me talk.
So my question to you will be then,
Yeah.
we've looked at the variation and genetics, because we know genetics can help and support fitness. Or we've looked at the peat grasses. So how does the knowledge of the differences, how's Vanessa now going to apply that in the boys and the team on the peaks to their support their conservation?
So, in the case of the peats grass, what we're looking at now is we're not looking at one population. So we're no longer thinking of this as an island whole thing. It's got to be split off into how do we conserve the barn grass, then how do we look at Diana's peat grass and the grass on High Peak, and how do we conserve those? And then how do we do that as an island thing all together? And at this point, what we probably want to do is separate those out and conserve them individually. And then what I would do is that we would then take seeds from these, take them back to Edinburgh, and then I can perform crosses, or Quentin can perform crosses of them to see what happens in when we cross these species. So the initial question that we'd be asking was, if we do cross things, does it increase the fitness of the plants, or does it decrease the fitness? And we may have to go through several generations to find out the answer to that question. But in doing that, we can build a much better model for conservation for that whole species on Ireland. And it's not a short-term thing, it's quite a long-term thing to go through. And if I can illustrate with another species that Quentin and I have also looked at, which is the Plantago, in difference to this, what we found is hardly any variation across the populations at all. Nothing. There is some morphological variation, but we've not got any genetic differences at all, which then means we can manage that as a whole population for the island. And that morphological variation gives us the ammunition to be able to look at things like the ability to adapt to climate change. So we've got a lot of morphological variation. It means that there is things to build upon there and to look at and to see how, under experimental conditions, we can change environments and what best survives. Does that answer the question?
Can I ask a question on hybridization? Is we as lead person, I've got no background in this at all, but we need to understand that you should keep the species intact and not having to be hybridized, like what's the avenue that's crossed with the
Remini.
red?
Remini, yes.
And
So-
am I right in thinking what you said, there are advantages if they do? Can I declare an interest as a hybrid myself?
And how vigorous you are, sir.
Yes.
But because my DNA is huge anyway. Not to say that I'm a good example.
No.
Yeah,
But I think that's exactly at the core of the
Yeah.
conservation question and challenge that
Yes.
we
When do
we
you do
now-
it or when don't you?
yes, exactly. And you know, conservation, like any science, is on a pendulum of which way to go and what's the right thing to do. And that's exactly what Quentin and Alan and Vanessa have been trying to sort out over the years, because it predates the PEACE project, the genetic work that they've been doing and trying to understand how the populations are working, and whether they're in fact actually more than one species. They might be subspecies or varieties or actually different species. But this question of hybridization is exactly at the core of that false gumwood, bastard gumwood argument, is that you have a false gumwood that's now down to 6 individuals in the wild. You have a bastard gumwood population that went down to 2. And due to the incredibly hard work that's gone on at the EMD over several years, you've got, in the 5th generation of pure bastard gumwood through that initial cross, and then multiple breeding up. So it's like a game of numbers, obviously. The quicker you can breed up in large numbers, the more chance you've got for reproduction, the more chance you've got for sort of for any variation coming through. And that has worked in terms of seemingly to producing what look like quite fit bastard gumwoods. We're a bit further behind with the false gumwood, which is why we're picking that up now, but that's not been reduced to quite such low numbers. So what happens when you cross those ones that are left? Is there enough fitness in the bastard gumwood population, the false gumwood population, to remain as 2 species completely separate and managed separately? Or, as the question is now, we have a false bastard gumwood hybrid that actually shows great vigour, and as Alan has said, has got genetic variation that's unique to either parent, because we've lost the parents that gave rise to those hybrids, but their genetics remain in the hybrids. So you could, in theory, do a back-crossing program where you take those, what would be the F1 hybrids, and any gardener would recognise the word F1, means bigger and you pay more for your seed. Whether those you can take and you can back-cross back towards a false gumwood or a bastard gumwood that's fitter actually than the parents would be. You just went through multiple generations of just pure species, and whether that's going to be, because we all know fit for the future, there we go at the moment, and this is about being fit for the future. We want we want our plants to be able to cope with the changes of climate change and other pests and diseases that are now existing on the island. So these are questions we don't have the answers to, we might never know the answers to, because we're talking about multiple generations over a very long time, but these are things that we can explore. And as an island, we can make decisions on about what's the best approach, and using the science to help guide and inform those decisions. And we have false bastard gumwood hybrids, we have large dwarf jellicoe hybrids, we have bellflower hybrids, we have red ebony hybrids. Hybridization exists in our flora. Some of it exists naturally, some exists unnaturally because of the changes that we've brought about. And I guess the question is, how best are we going to utilise that hybridization to make sure that we have got healthy, fit plants that are going to contribute to the restoration of not just Diana's Peak, but other areas as well. So we have got these plants for the future.
As usual, that means put your finger on
Exactly, the key point.
So I don't want to, but hybrids are a big interest of mine, so I can't resist just adding something. And that, down in Barren Ground, there's a little living gene bank of the hybrids that Alan was talking about, and that's actually not threatening anything, and it's not threatening the pure species because we don't gather seed from around there, but it's actually an insurance policy. The hybrids, because they're more vigorous, can be an insurance policy. Okay, so hybrids actually have a conservation role as insurance, and it's the same with the redwood ebony hybrid. If it's grown somewhere where nobody's going to gather seed of pure ebony or gather seed of pure redwood, it's not a problem. It's not a threat, and it's a lovely plant. So I think it's if by some disaster we lost the redwood, which is quite a rare thing, even with the planting that's been done, having a hybrid would save all the redwood genes in that hybrid, which I think is a really good insurance policy, as long as they're grown apart from the others. Does that answer your question?
Yes, thank you.
But what about the unique invertebrates that are present on those wild trees that when they die will go, that I know are on them?
Well, maybe this is really an idea out of left field a bit, but maybe if the invertebrates, if say pure redwood is not able to sustain all the invertebrates, maybe one could set up somewhere well away from wild redwoods a population of hybrids, which could then maybe support some of the invertebrates. And
That's exactly the false government question, is that you have a unique endemic on the false government at Mount Beeson, which is false government leafhopper. It's only on that population, yet through this work Vanessa is creating new populations of false government, and we have the hybrid. So is there an opportunity where not just the hybrids can be a safety net for the false government, or the gene banks can be a safety net for the false government, but actually they can be areas that you can now translocate critically endangered, restricted endemics, and that's the same with the so we don't know if something is obligate can only live on the false government and it couldn't live on the false bastard government hybrid, or we don't know if the moth that is known on the peaks grass, whether by hybridizing the barn grass it still likes the conditions that it finds. So that's again, that's that sort of, it's a holistic approach. It's not just saving plants for saving the plant's sake. It's actually that actually there's a whole ecosystem happening, and more that we don't know in terms of other relationships that are going on. So yeah.
One of the things we were able to do with the analysis that we did was we were able to look at some of those hybrids and determine which ones were actually closer to bastard government and which ones are closer to false government. And those are all numbered, they've all got individual identities, so we can go back and we can trace that and we can use them as a stock to test out some of what Rebecca's talking about.
And we also can see from them, so we can store as well. It's a longer the hybrid seed. There's another one on 14, keep the years.
So yeah, if you want to go and have a look at some of the plants and ask some questions, and should we turn the microscope
So
also at the front a vegetarian and gluten-free option, but I do ask that if you're not vegetarian or gluten-free, save it for those that are.
You see a difference?
So,